So question 9, solve the following equation by factoring. So again, the right-hand side is equal to 0, so all we have to do is figure out is the left side factorable. So notice how we now have a coefficient in front of x squared. So we now have the form ax squared plus bx plus c. Now the strategy here is, since there is a coefficient in front of the x squared, what we do is we multiply the a and the c together. So we multiply this thing will come on for me. So we multiply the A and the C together. So that's at A times C. And then that answer's factors must add up to equal the B. So then we involve the B. So a lot of times what I'll do is I'll use a T-chart for this. And also, when it comes to the factoring, on this one, I actually use Foursquare. I use a big old box here as an organizer. So this is kind of some old school way of doing it. So in the Foursquare, the quadratic term goes to the top left. The constant, the 15, goes in the bottom right. So what we do is we now can go ahead and do this strategy, A times C. So 2 times the 15. That's going to give me this 30. So the 30 goes here. So the factors of 30, that's where this is coming in. The factors of 30 must add up to equal to B. So the B is this negative 11. So what we're trying to do is figure out what are the factors of a 30 that give me a negative 11. Well, 30, the first thing that actually comes into my mind is a 5 and a 6. So without further ado, I'm just going to write down the 5 and the 6 here. But to get a negative 11, it looks like they both have to be negative. So does a negative 5 times a negative 6 give me a positive 30? Yes. Does a negative 5 plus a negative 6 give me a negative 11? Yes. So what happens is these become the coefficients of the linear term. So this negative 11x gets broken into two pieces, minus 5x and minus 6x. So it completes our box. And then from here, what we can do is factor out a common factor. So between the 2x squared and the negative 5x, they do have a common factor of x there. Now, to make this easy, that's all I'm going to do and just start kind of playing with it. So what times x gives me 2x squared? Well, it looks like since I took an x out, I should have a 2x left over. 2x times x is 2x squared. That checks out. And if I take the x out of the negative 5x, that just leaves me the negative 5. Does negative 5 times x give me negative 5x? Now, notice what gives me the negative 6x will be this factor and this factor. So if you ask yourself, 2x times what gives me a negative 6x? So in other words, we're taking a 2 and an x out of this, going this direction. So that's going to leave me a negative 3. So does negative 3 times 2x give me a negative 6x? Yeah. So if we take a 2 and an x out, that just leaves me the negative 3. And then negative 5 times negative 3 has to give you this piece here. Does negative 5 times negative 3 give you this piece? Yeah. So we're actually kind of done. So these two edges become our factorizations. So x minus 3 becomes one factor, and the 2x minus 5 becomes the other factor. Now the catch is, since it's factored to equal 0, one of these factors has got to equal 0. So it is, we just set x minus 3 equal to 0. And then we also set the 2x minus 5 equal to 0. So this now just turns into two little linear equations. And if we can solve these equations, well, this one's not so bad, x equals 3. But this one's got a couple of steps. You got to move the 5 over. 2x is equal to 5. But then you got to divide each side by 2. So that equals then 5 over 2. So we have two answers, 3, and the other answer is 5/2. So that would be our two answers. So x is going to equal 3 and also this 5/2.